Welcome back to the logical reasoning sessions. Today we'll go for an interesting area called cubes. Well, this is a kind of question we have in front of us. A cube is painted with violet color on all the faces and that's cut into 125 smaller but identical pieces. So we have a solid cube that's cut into 125 small but identical pieces. So that's what we have in front of us. This is what it is. So, well, it is one face of that cube. So it is 5 into 5, 25. So then we have such layers. So total 125. Then how many of the smaller cubes have exactly one face painted? A cube has 6 faces. This is one of the face. How many of the smaller cubes have exactly one face painted? If you look at the cubes on this side, you know what, this side is painted, and if it is a cube, this side is painted as well, right? So that's edge. Edge, 2 sides painted. This edge, 2 sides painted. This side, 2 sides painted as well. So however, if you look at the cubes in this area, it's just one side painted. One face of the smaller cube is painted. How many such cubes we have? That's pretty much 9 cubes on one face. How many such faces? We have 6 such faces, correct? 6 faces like this. So 9 into 6, 54 is the answer right here. So now we'll go for the next question, 27. How many of the smaller cubes have exactly 2 faces painted? Well, the direction is exactly the same as the previous question. Solid cube painted with violet color, and that is cut into 125 smaller but identical pieces. How many of the smaller cubes have exactly 2 faces painted? Now we look at this diagram over here. Which are the cubes with 2 faces painted? 2 faces painted. Actually, this is, if you kind of like imagine a Rubik cube, the cubes at the corners are like 3 faces painted. However, this cubes over here is 2 face painted. This is 2 face painted. This is 2 faces painted. And this is 2 faces painted, 2 faces, 2 faces. And this is 2, 2, 2. And this is 2, 2, 2 as well. So ultimately, if you look at this way, on an edge, if you assume that this is an edge, so this is one of the edge of the cube, and well, how many such cubes? How many cubes with exactly 2 faces painted on one edge? There are 3 of them, right? And how many such edges for a cube? So if it is a cube, we see 4 edges here, right? And similar face at the back, we have 4 edges, and we have edges through the middle portion as well, that 4 edges. So ultimately it is 4 plus 4 plus 4, 12 edges. So one edge we have, how many? 3 of them. So how many edges you have? 12. 12 into 3, 36. So, well, 36 cubes. This is the question. How many of the smaller cubes have exactly 2 faces painted? 36 cubes. Next, what we have is question number 28. Question number 28, how many of the smaller cubes have no paint at all? So this is the cube we have. All the outer sides are painted. However, inner side there is no paint. So how many such cubes are in the inner side? Inner side, if it is, this is a 5 into 5 into 5 cube. That means it's 125 total smaller cubes, right? So 125 means 5 lengthwise it's 5, breadthwise is 5, depth or height is 5 as well. So it's 5 into 5 into 5 cubes. So 5 into 5 into 5 is 125. So that 125 cubes, we write it as 5 into 5 into 5. 5 into 5 into 5. In order to get the cubes without the paint, we have to have the inner cubes. Inner cubes, 3 into 3 into 3 would be the inner cube. 3 into 3 into 3, the inner cube, that was equal to what? 27 cubes. So the answer for this question, no paint at all, 27 cubes. Next one. How many of the smaller cubes have at least 2 faces painted? At least 2. Well, at least 2 means exactly 2 plus something more than 2. So exactly 2 faces painted. The previous question we have here. Exact 2 faces painted is 36. So we have 36. That is 2 faces painted, 2 faces. And some of the cubes, we have more than 2 faces painted. That means 3 faces painted, 3 faces. That's corner cubes. Corner cubes with 3 faces painted. How many such corner cubes we have? 8 corner cubes. So 36 plus 8, 44. So the answer is 44. Next one. How many of the smaller cubes have exactly 2 colors on them? This is a different question. So this is what the direction is given here. A solid cube is painted with blue color on 2 opposite faces. So blue color on 2 opposite faces, green on the other 2 opposite faces, and red color on the remaining 2 opposite faces. So 2 opposite faces, we have blue, and green on the other 2 opposite faces, and we have, what is the other color? Blue, green, and red. So 3 colors. The cube is cut into 200 and smaller but identical pieces. 216 means it is 6 into 6 into 6 cube. 6 into 6 into 6. That is 216. So that means lengthwise it is 6, breadthwise is 6, and heightwise it's 6. So let's draw that cube here. And we'll make it as a grid, right? So this one face of the cube would be like this. So it's total 216. So we are just, drawing just one face of the cube. This is what we see, and the question is the cube is cut into 216 pieces. Then this is what the question: how many of the smaller cubes have exactly 2 colors on them? Exact 2 colors on them. 2 colors on them are the cubes which are on the edges. For example, this side, let's say this side is blue color, and if you have this side is green color, so blue here and this must be green, right? Or green here, and if it is blue here. So these cubes, they have 2 different colors. And this corner cube, this side would be green, this side would be blue, and this side would be red as well. So 3 different colors. So we are not really looking at the corner cubes, but we are looking at the cubes on edges other than the corner cubes. So how many? These are the cubes. 2 sides painted, 2 sides painted, 2 sides painted, 2 sides painted. So how many of the smaller cubes have exactly 2 colors? Exact 2 colors. So these are the cubes with the 2 colors. And this side, this edge, we have 2, 2, 2. That means 2 indicates 2 faces painted with 2 different colors. And 2, 2, 2, 2. So each edge, we have 4 such cubes with 2 different colors on it. And how many such edges we have? Well, 12 edges. For a cube, we have 12 edges, right? So 12 into 4, 48 would be the answer, 48. And we'll go for next question. Next question is based on the similar direction, same direction. So that is blue color on opposite faces, green on opposite faces. Then the cube is cut into 216 pieces. And how many of the smaller cubes have no blue paint on them? First of all, the best way to get the answer, how many of the smaller cubes have blue paint on them? Blue paint are on 2 opposite faces, right? So one face, there are 36 cubes because it's 6 into 6. 6 into 6, 36 cubes on one side, the other side, opposite side, we have 36 as well. So 36 plus 36, 72. So 72 cubes have blue paint. The question, how many of the smaller cubes have no blue paint? So total 216 minus 72. So 72 is subtracted from that. What you get is 144. So 144 cubes, it doesn't have, those cubes don't have blue color. So that 144 cubes, some of them have red color, some of them have green color, some of them have no color. Ultimately, those cubes have no paint at all. No blue color on them. Some of them have a different color, some of them have no color, doesn't matter. They don't have blue color on it. So that's what it is. Now 32. 32, how many of the smaller cubes have at least two colors on them? At least two. That means either two colors or more than two colors. So we'll take a look at that. How many of the smaller cubes have two colors on them? Two colors on them, we have 48. So the question we have in front of us, question number 32, at least two colors. So two colors is 48. Two colors, 48. And at least two colors means two colors plus anything more than two colors. So we have three colors. Some of the cubes with the three colors. How many of the cubes with the three colors? These are the cubes at the corners. So there are 8 corner cubes. So 48 plus 8, that's the answer, 56. So here it is. Now next one we have is how many of the smaller cubes have at most one color on them? At most one. The maximum one color on them. Maximum one color on them. Maximum one. So it could be one or less than one. So, well, one color. How many cubes with one color on them? Plus the cubes with no color. So at most one means maximum one. So maximum one. Maximum one color means it is one or less than that. So less than means, less than one color means there's no paint at all. There are cubes with no paint at all. So first of all, we take one color. How many cubes with one color? So when you look at one face of this cube, it's here. One face of this cube, you see that, let's say this is the face with the blue color or green color, doesn't matter. So if this is a face with the green color, then these are the cubes. You look at this cube, it's just one face is painted, just one face. So how many such cubes? 1, 2, 3, 4, 5, 6, 7. Actually, you take it this way, 4 into 4. 4 into 4, there are 16 cubes. These cubes exactly one face painted, right? One face. So there are 16 cubes on one face. However, how many such faces we have? 6 such faces. 16 into 6. 16 into 5 is 80. 16 into 6 is 96. So we have 96 with exactly one face painted or one color. So 96 plus no color at all. No color means the cubes which are inner cubes. This is 216 cubes. 216 is 6 into 6 into 6. If it is 6 into 6 into 6 cube, what is the inner cube is? 4 into 4 into 4. 4 into 4 into 4. So that's the inner cube. Inner cube means cubes without any paint at all. Cubes without paint. So inner cube. So 4 into 4 into 4 is 64. We have 64 cubes without any paint at all. So the maximum one color is, maximum one color means either one color or less than that. So we have 96 plus 64, we have 1/6, so 160 cubes. Now, how many of the smaller cubes? So, well, the question, the direction is slightly different. A solid cube is painted with white color on two adjacent faces. In this case, white is on two adjacent faces, black is on other two adjacent faces, and the pink color on the remaining two adjacent faces. In this case, painting is on adjacent faces. Two adjacent faces are painted. Then the cube is cut into 125 small but identical pieces after the painting. Okay, so let's take a look at how many of the smaller cubes have white paint on them. White paint. Let's try this. Let's try to make it as three-dimensional. Well, I don't think we can make it on using that. Well, let's make it two-dimensional, then we'll draw it from there. Okay, so here is a cube. I'm just trying to make it three-dimensional. All right, so this is one of the white face and this is another white face. So the question is, how many of the smaller cubes have white paint on them? So there's 25 of them we have white paint, and here another 25 we have white paint. However, when we count it, you know what, if it is a Rubik cube, probably you notice that when you count it, these cubes, these 5 cubes, and these cubes, actually these faces you see here, these faces are the part of this cube over here. This cube, one face of this cube, this is another face of this cube. So ultimately, when we count the cubes on the edge, what we count here inclusive of these cubes over here. So ultimately, so here we have 5 cubes and this part is counted as well. So ultimately you can count it this way. When you take this 25, this part is included. This part is included. So total 25 up to here. Then we have 1, 2, 3, 4 and the 5. Lengthwise it's 4 and breadthwise it's 5 as well. So 5 into 4 we have 20 here. So already 25 here plus 20 here. So total that's 45. However, these white faces are on two opposite sides. Then we have 25 on one side, it's 25 white, and another 25 on the other side. So 25 plus 25 we have 50. But if this is adjacent, then we have what, 25 plus 20. So that's 45 is the answer, 45. Now, how many of the smaller cubes have exactly 3 colors on them? Okay, let's take a look at that. 3 colors. This is what we have, 2 white adjacent, right, 2 adjacent white, then we have black on other 2 adjacent faces. So where is black? Here we can assume that here is the black and the bottom side can be black. And this side we cannot see, that side can be the other color which is missing. What is it? Pink. So pink could be on this side which is missing, and pink could be on the back as well. We cannot see that. So this is black and this bottom is black as well. So that is, let's assume that that's a painting. And how many of the smaller cubes? Well, this is the question. How many of the smaller cubes have exactly 3 colors on them? 3 colors. If you look at this cube, this has the white color here, and this is a white color here. And if you take this black here, so this cube, then of course we'll have cubes on that side. Let me draw it. Once we complete it, you get a clear idea about it. This side, what I'm drawing right here, it's black face. But if I draw with the black lines, probably you cannot really see that. So that's the reason I'm using a different color here. All right, so look at this cube here, white here. And this side is white, 2 adjacent white sides. And this side, we assume it's black. So black color. Okay, so this side is completely black. So here it's black. So when you look at that corner cube, it has 2 white colors and 1 black color. So how many colors? 2 colors altogether. And the question we have is, this is what the question is. How many have exact 3 colors on them? So if you look at this corner cube, it has only 2 colors. When you look at this corner cube, what you see here, this is white, this is black, and the back side we assume that's a pink color. So this cube has 3 different colors. This corner cube has 3 different colors. And how about this corner cube here? This is white, and the back side is pink, and this side we assumed it's pink as well. So it's pink. So it's pink, pink, white. So that means 2 colors. This is the only cube we have seen so far with the 3 different colors. And look at this cube here. It's white, and this side is white, and this side is pink. So it's white, white, pink. So that means again 2 colors. Now look at this cube over here. This is white here, and bottom we assume it's black, and this side is pink. Okay, so it's 3 different colors. So this cube we have 3 different colors, this cube we have 3 different colors. And how about this cube we have? White, and this side is black, and the bottom is black. So it's black, black, white. So again, 2 different colors. And how about this corner cube here? This corner cube we have black on the side and pink here, and the bottom is black. So it's black, black, pink. So again, 2 colors. Ultimately, we have 2 different cubes. That means 2 corner cubes. Actually, we have 8 corner cubes. Out of that, 2 corner cubes have 3 different colors. The other 6 corner cubes, they have only 2 different colors. So that's what? So the answer for this question, how many of the smaller cubes have exactly 3 colors on them? The answer is what? 2. 2 of the corner cubes have exact 3 colors on them. 3 colors. This is what the question, 3 colors. Now, next one, how many of the smaller cubes have 2 colors on them? 2 colors. This case, this is what the diagram we have. How many of them have 2 colors on them? Actually, if you look at this edge, this is white on this side and white on this side. So the cubes on this edge, they have only 1 color. 2 sides painted, but only 1 color. And how about the cubes on this edge? This edge we have white, 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 and this side is black, black, black. All right, so corner cube, when you look at that, that would be confusing. We'll take a look at corner cube later. So we are looking at the cubes on the edges other than the corner cubes. We are looking at these 3 cubes. So this is 1 cube, and this is one side of that cube. This is the other side of the same cube. And this is one side, this is the other side. So ultimately, on that edge, we have 3 cubes other than the corner cubes. So there are 3 cubes. We say that this side is white and this side is black. So 2 different colors. Our question, how many of the cubes with 2 different colors? So here on the edges, we have 3 cubes. However, on this edge, we don't have that because it's white and white. So white and white edge, we have cubes with 2 sides painted, but it's only 1 color. Both sides it's white. Same way with the edge on black and black. Black and black edge, we have 2 sides painted, the cubes with the 2 sides painted. However, it's same color. So we have to avoid that black and black edge, white and white edge, and pink edge. Total 12 edges. Out of this, black and black is out, white and white is out, pink is out. So 3 edges are out. Balance, we have 9 edges. Out of that 9 edges, we have each edge, we have 3 such cubes with 2 different sides painted, 2 different colors. So 3 into 9, that's 27. So 27 cubes with exactly 2 sides painted, 2 sides painted with 2 different colors. 2 different colors. So how many are there? 27. Actually, this is the answer for not this question. The question we have, what is the question number? I think 36. Okay, so we'll get into that question later because we have the diagram here. That's the reason we keep writing on this board and this slide. Okay, let's look at that 27 plus. How many of the cubes with 2 colors? These are the cubes with the 2 sides painted with 2 colors. At the same time, we have these cubes, corner cubes. Well, this cube has 3 different colors. However, look at this cube, pink and white. So that means it has only 2 colors. 3 sides painted but 2 colors. And this one, it's white and white, pink. So that means it has 2 colors. Then we have white and white, black. So ultimately, 8 corner cubes, 2 of them has 3 colors and 6 of them have 2 different colors. 3 sides painted but 2 different colors. So ultimately, we have 27 plus 6, 33 would be the answer, 33. So 33 would be the answer for the question here, 36, question number 36. How many of the smaller cubes have 2 colors on them? Well, some of these cubes have 2 sides painted, two sides painted with two colors, it's 27. And some of the cubes have three sides painted but two colors. So that means 6 of them. So ultimately we have 33. Next one. How many more smaller cubes of same size required to make a complete outer cover for the given cube, which consists of 125 smaller cubes? So we need to make an outer cover. So if you make an outer cover for a cube, this is 125, this is 125 here, right? So if you want to make an outer cover, we have to cover all the sides. So if we have 5 cubes here, it is exactly covered only this area, but we need to have one extra on this side, one extra on this side. So it's complete, all the faces must be covered. So ultimately, when you make an outer cover for this cube, the size of that outer cover would be one extra on this side, one extra on this side, one extra on this side, one extra on this side. So that's the way it works. So this is 5 into 5 into 5 cube. So outer cover would be, the size of the outer cover would be 7 into 7 into 7. So when you look at that, if you see a cardboard box which covers any item you buy, you see that all the faces are covered. So that cardboard box would be larger than the item you buy. So that's the case, and it covers extra on this side. That means that's protruding to that side as well, right? So left, right, top, bottom, everywhere. So same case here. So it's 5, then we have one extra here and one extra here as well. So that's 5 plus 2, 7. So 7 into 7 into 7 is the size of the cube, outer cube. Now the question is, how many of the smaller cubes of same size required to make a complete outer cover? So size of the outer cover is 7 into 7 into 7. That is 343. However, we have already that 125 cubes inside. That space is filled with that 125 cubes. So we need only that extra cubes which came after this 125. So that means this 125 must be subtracted from the total. So 343 minus 125. So it's 345 minus 125. If that's the case, it's 220. 345 minus 125 is 220. Here it's 343. So the answer must be 218, right? 218. Okay, so how many of the smaller cubes required? 218 smaller cubes required to make an outer cover. Now, how many of the smaller cubes have only silver color on them? So that's based on the directions given over here. A cuboid with sides 3 centimeters, 4 centimeters, and 5 centimeters is painted with maroon color on two opposite sides, measures 5 into 4. 5 into 4 is maroon color. Yellow color on two opposite faces measures 4 into 3. 4 into 3 is what? Yellow color. And the silver color is on the third opposite face, measure 5 into 3. 5 into 3. So it is 5 into 4. Then the other side is 4 into 3. Then we have 5 into 3 as well. So it's a cuboid. So let's try to draw a cuboid. That would be interesting. So 5 into 4, this is actually 5 into 5. We have to make it 5 into 4. So that's what it is. One face must be 5 into 4. And the other one would be what? 4 into 3. 4 into 3. Then we have 3 into 5 as well, right? So this is pretty much 4 into 3. So it's pretty much what? 4 and 3. 4 into 3. And we have what is another one is 5 into 3. So 5 into 3. Well, this is 5 here. And this side would be 5 into 3. So we'll draw that as well. So these ones, it doesn't seem exact like a cube, but no need to worry about it. Assume that these are the cubes. And this is what? This is 5 into 3 sides. So this is what the cuboid you have. And of course, let me complete this part as well. So this is what the cuboid we have. So it's 5 into 4 face right here. And the back side we have another 5 into 4. This is pretty much 4 into 3. And this is 5 into 3. So that's how it is. Okay, so let's do the quotients. How many of the smaller cubes have only silver color on them? So silver color is where? Silver color is on the third set of opposite faces, measure 5 into 3. So 5 into 3, that's with the silver color. So 5 into 3, this is a silver color. So 5 this way and 3 this way. So 15 of them. And definitely on the opposite side, we have another 15. So this side we have 15 and the other side we have 15 because silver is on two opposite faces. So that means 15 plus 15, the answer is 30. So we have the answer 30 for this question, and we go forward next question here. Same direction, and how many of the small cubes are, or smaller cubes are there with exactly 2 colors on them? 2 colors. So let's check it out. Two colors, actually, we are looking at the cubes on the edges. So edges, this edge we have 4 cubes. Out of that, this corner cubes, we have 3 different colors. This side is, what is it, maroon, right? Yeah, 5 into 4 is maroon. Yellow color is 4 into 3. So this is yellow, this is maroon, and this is silver. And if you look at corner cube, this is maroon, this is yellow, this is silver. So that is what it is given. Now the question, how many of the smaller cubes have only, okay, silver color on them? That question we have done. This is exactly 2 colors. Exactly 2 colors. We look at the edges, and this edge we have 2 different colors. This is maroon, this is yellow. And actually this corner cube, it has 3 different colors. So we are looking at these 2 corner cubes. And not corner cubes, these 2 edge cubes. Corner cubes we don't need to consider. So we have 2 of them here, and we have another 2 here. So how many such edges you have? With exact 2. So this edge, and similar way we have a bottom. There are 2 edges more. So 2 into 4. So 2 into 4. Now we look at these edges over here. These edges we have maroon. So this is maroon, this is maroon, this is maroon. So this side is what? Silver, silver, silver. But when you look at this cube, it's what? 3 sides painted. But this cube, this is one single cube, this side and this side, maroon and silver, maroon and silver, maroon and silver. This is again a corner cube, 3 sides painted. So again, we have 3 such cubes on that edge. So how many such edges we have? 1, 2, then other 2 on the opposite sides as well. So we have 4 such edges. 4 into 3, 12. So 3 into 4 such edges, that's 12. So 2 into 4, we have 8. Now we have any other edge we have. Just missed it out, 3 into 4. So 3 into 4, yeah, 3 into 4 we have edge we have taken. So 5 into 3 we have taken. So 3 into 4 and 5, now 5 and 4. 5 and 4 edge, well, this is what actually 5 and 4 edge. 5 and 3, this is what 5 and 3. Now we have to take the 4 and 3 edge. 4 and 3 edge, where do you take that 4 and 3 edge? The edge we haven't taken. See that, this edge, 3. This edge, we have 4. So that's the 4 and 3 area. So that means we have 1 cube on that edge. That's 2 sides painted, 2 sides painted. And this one, it's corner cube, 3 sides painted. This is again 2 sides painted. So there are 2 cubes here. And these cubes are already been taken, these cubes. So 2 here, and we have bottom, there are 2 as well. So ultimately, we have 1 cube on one edge, 4 such edges. So 1 into 4. 1 into 4 is 4. So we have 24 such cubes. 24 such cubes. So this is what the question, 24 such cubes are there. Next one, how many of the smaller cubes have no maroon color on them? So this is what, the same direction. How many of them have no maroon color on them? So that means we have to take the inner cube. So what is the size of this cube? The size, well, it is 5 into 4 into 3 is the size of this cuboid. Actually, it is not a cube, it's a cuboid. And what is the inner size? Inner size would be, that means inner cubes without color, without paint. So that would be 3 into 2 into 1. Remember, 5 into 5 into 5, if it is the size of the cube, then inner means without paint, that would be 3 into 3 into 3. That means 3 into 3 into 3 means n minus 2 into n minus 2 into n minus 2. So what is n here? N is 5. So 5, 5, 5. So 5 minus 2, 3, 5 minus 2, 3, 5 minus 2. So here, take it same way, n minus 2. So 5 minus 2 is 3. Here n is 4. 4 minus 2 is 2. 3 minus 2 is 1. So 3 into 2 into 1. 3 into 2 into 1, 6. So that's the answer. No maroon color on them? 6 of them. I think there is some kind of a confusion with the answer choice. No need to worry about it. So that's what it is. Oh, sorry, my mistake. What we have answered here, the number of cubes without any color on them. So that is, the answer is what? 6. However, this question is asking for how many the smaller cubes have no maroon color on them. So actually, we are just trying to get rid of the cubes with a maroon color. How many of the cubes with the maroon color? Maroon color is painted on the face, which is 5 into 4. So 5 into 4 face, that's a maroon color. So one face we have 5 into 4, 20 cubes with maroon color. On the opposite side, we have 5 into 4, 20. 20 plus 20, 40. So 40 cubes we have with the maroon color. What is the total number of cubes we have? 5 into 4 into 3. So 5 into 4 into 3, 60. 60 out of 60, 40 have maroon color. So the balance is 20. 20 without maroon color. In that 20, we have that 6 cubes which they have no color on them. And the other 14 cubes have some color, some kind of different colors other than maroon color. So altogether, there are 20 cubes without maroon color. So the answer is 20 right here. However, if they ask you the question, how many of the smaller cubes have no color on them, no paint at all, then the answer must be 6. Okay, that was a confusion we had. So now that's cleared. So in this case, the answer is 20. And if they have the question, if you have the question, how many of the smaller cubes have no paint and no color, that means 6. Now 41. These are like blood relation questions, and we have done these questions earlier. We have done the basics of these questions earlier. Now these are practice questions. Pointing to a woman, Abhijit said, her granddaughter. Okay, so pointing to a woman. So let's say a woman is here. And her granddaughter. Abhijit says her granddaughter. That means her daughter's or son's daughter. So granddaughter, we call it GD. Granddaughter. And this is a woman, so you mark it as female. So this is a female as well. So while pointing to a woman, Abhijit said her granddaughter, this woman's granddaughter is the only daughter of my brother. Okay, so this granddaughter, that's the only daughter of my brother. Who said it? Abhijit said it. Abhijit said it. Abhijit got a brother. And so this is the brother of Abhijit. So we mark it in such a way that this is Abhijit and this is the brother of Abhijit. So Abhijit and this woman, of course, since this woman is the mother of Abhijit's brother, then that woman would be the mother of Abhijit as well. So this Abhijit and the brother, they are the siblings, and this is the mother. So her granddaughter is the only daughter of my brother. So how is the woman related to Abhijit in that case? So from Abhijit's point of view, who is that woman? So that woman is who? Mother. So this case, we don't have any kind of confusing answer choices here, like data inadequate or cannot be determined. We don't have such an answer choice. So we confirm the answer is mother. However, just for you to aware of the similar type of questions, just in case, if it comes with an answer choice data inadequate, you have to be aware of a second possibility here. So we'll take a look at what is that second possibility. So pointing to a woman is the woman. Abhijit said her granddaughter. So this woman's granddaughter. So that woman's son's or daughter's daughter, granddaughter. So we call it GD. Granddaughter. So this woman's granddaughter is the only daughter of my brother. So Abhijit has a brother, and the brother is married to this woman's daughter. So this woman's daughter. So this woman, her daughter's daughter is her granddaughter. At the same time, from the Abhijit's point of view, Abhijit's brother is married to the daughter of this woman. So this woman's granddaughter is the only daughter of Abhijit's brother. Conditions are perfectly all right. However, the relation is totally different here. Now look at that woman. That woman is Abhijit's brother's mother-in-law. It is not the mother of Abhijit's brother, it's a mother-in-law. Same way, from Abhijit's point of view, who is that woman? Abhijit's brother's mother-in-law, that is the answer. It is not the mother. So this case, we don't have such an answer choice. That's brother's mother-in-law. That answer choice is not given to us. So we don't need to worry about that possibility. However, if you have an answer choice data inadequate, definitely the answer must be data inadequate. The reason, we have two different possibilities for that question. So that makes that question really challenging if you have a question with the answer choice data inadequate. This case, if that question comes without the answer choice data inadequate, that question is easy then. All right, let's go for the next one. A plus B means A is the sister of B. Okay, so let's define those relations. A plus B means A is the sister. A is the sister of B. Then A into B means A into B. A is the wife. A is the wife of B. And A percentage B means A is the father of B. A percentage B. A is the father of B. So it is plus means sister, and multiplication symbol means wife, and percentage symbol means father. So here it's sister, wife, father. And A minus B means A is the brother of B. A minus B means A is the brother of B. Which of the following means T is the daughter of B? So among the answer choice, which of the following means T is the daughter of B? So this kind of questions, we have to do a trial and error method because we have no idea which answer choice is correct. So we'll start from either from answer choice 1 or you can start from answer choice 4, doesn't matter. Well, usually sometimes it happens, it's really funny sometimes. If you start from answer choice 1, then you go for answer choice 2, then you go for 3. That case, probably answer choice 4 is the answer. is the correct answer. But if you start from answer choice 4, then you go for 3, then you go for 2, etc. That case, probably answer choice 1 would be the answer. It's called Murphy's law. Anyhow, we cannot really predict which is the answer. We'll try it. Here, first one, P into Q. So P into Q means, well, this is what? P is the wife of Q. And Q percentage R means Q is the father of R. R plus S means R is the sister of S. And S minus T means S is the brother of T. So at a glance, if you get that answer right there, or if you are a bit of confused, then what we do, we'll just make a diagram. So P and Q. P and Q, P into Q means P is the wife of Q. P is the wife of Q. So P is the wife of Q. P and Q are married. P is the wife of Q. This plus sign indicates that P and Q are couples. Okay, now what is it? Q percentage R. That means Q is the father of R. Q is the father of R. So since Q is the father, we'll just mark it with a male symbol. So this sign indicating the male. Then R plus S. R plus S means R is the sister of S. R must be the sister of S. So R is a female and S. R is the sister. And next is S minus T. So S minus T, well, that indicates S is the brother of T. S must be the brother of T. So S is a male, S is the brother of T. And what is the question? Which of the following means T is the daughter of P? Well, this case, T, can we say that T is the daughter of P? Well, in this case, we have no idea what is the gender of T. So we are not sure about it. Question mark. So answer choice 1. This is answer choice 1. Now we can think about answer choice 2. Answer choice 2, well, this case, what is it? P into Q. Well, we are looking at answer choice 3 right now. So P into Q. So this is pretty much exact same as what we have here. P into Q. So that means P is the wife of Q. Then Q percentage R means Q is the father of R. Then R plus T means R is the sister of T. R is the sister of, this case it's given as R is the sister of S. So next possibility, R is the sister of T. Now, next one, T minus S means T is the brother of S. So T is the brother of S. And what we need, which of the following means T is the daughter of P? This case, clearly we know that T is the son of P, right? So this one cannot be the answer. Now here, the first few things are exactly same. So we'll go for same diagram. Same diagram is good enough. If you want to draw a new one, that's fine. Otherwise, you can just solve it with the same diagram. So since we need to avoid as much as confusion, we can. So what we do, we'll go for a new diagram to avoid confusion here. Otherwise, if you are comfortable doing with this diagram, that's good enough. So let's try this. P and Q are married. So P is a female and Q is the father of R. Q is the father of R. So Q is the father. Then R minus T. R minus T means minus is what? R. R is a brother of T. R is the brother of T. And T plus S. T plus S means what is it? T is the sister of S. T is the sister of S. So that case, we know that T is the daughter of P. Perfectly all right. So second one, we got the answer right there. So that means we don't need to check the answer choice 4 exam point of view. But in classroom practice, we can take a look at that as well. So this answer, if you look at this one, P plus Q. So that means P is the wife of Q. P into Q. When we write it, I'll just put a plus sign over there. That plus sign indicates P and Q are couples. Don't confuse. Plus sign indicates P and Q are couples. So P plus Q. So P is the wife of, P into Q. P is the wife of Q. Then Q percentage R means Q is the father of R. So we are looking at this. Then R plus S. What is that R plus S? R plus S means R is the sister of S. So this case R is the sister, R is a female. R is the sister of S. Then S plus T means S is the sister of T. So that case S is the sister of T. S is the sister of T. Well, that case, the gender of T, we are not really sure about it. So if the gender of T, we are not sure about it, then we cannot say that whether T is the daughter of P or not. So fourth one, again, we are not sure. So first answer choice, we are not sure. Fourth answer choice, we are not sure about the gender. And third answer choice, we know that the gender of T is male. So that means T cannot be the daughter. Then the only answer choice which gives us the definite answer is answer choice 2. So that would be the final answer for this question. Now 43. These are the logical Venn diagram questions. Which diagram is most suitable to indicate the relation among India, Haryana and world? So we know that India is inside the world, right? So world, then India. Then, of course, Haryana is inside India. So, Haryana is here. Ultimately, what is that answer? Fourth one. At a glance, you can get the answer. Simple question. Number 44. What is that? Which diagram is most suitable to indicate the relation correctly among pigeon, bird, and dog? So, well, pigeon is a bird, right? So, pigeon is a subset of bird. So, we have bird. Inside that, we have pigeon. At the same time, we have a dog circle as well. So dog circle is totally different. Dog is not pigeon and dog is not a bird. So that is the answer. If you look at that way, which is the best answer here? 1. Next one. Number 45. Doubt is to faith. So doubt and faith, what kind of relation there? So there is some kind of relation. Either you look at the meaning of these two words, doubt, faith. So, well, doubt is pretty much antonym of faith, right? So if you have faith in something, if you doubt, then you don't have the faith, right? So that's what it is. Then we look at the similar relation among the answer choice. So these are just opposite in meaning, right? Opposite in concept. So we'll go for atheist and religion, skeptic and pious, and iconoclast and idol, apostate and state. So actually, when you look at this way, the best answer is here, skeptic and pious. Skeptic. The pious is somebody who's kind of worshipping something, right? So especially gods and those kind of things. And skeptic, the person who is skeptic may not do that. So skeptic and pious, that's totally different. I mean, meaning is totally different. So that's the answer. Number 46. Brick is to building. So brick and building. Brick is used to make the building. Brick is the raw material for the building. Brick is inside the building. So these are the relations we have there. Then word and dictionary. Okay, word is inside the dictionary. That's correct. Alphabet inside the letter. Well, alphabet and letter are similar things, right? So that doesn't work. Platoon and soldier. So platoon inside the soldier. Actually, the soldier is inside the platoon, or soldier is a part of platoon. So soldier is a subgroup and platoon is not a subgroup. Then idiom and language. Well, idiom is, well, of course, idiom is a part of the language. That's correct. Idiom is not really, the building block for the language. It's not the raw material. Language is not made from idioms. Idioms, yeah, it's part of the language, but its language does not come from idioms. Not necessarily, right? So if that is the case, the best answer you have here, word and dictionary. Actually, words are inside the dictionary. So bricks are inside the building. Or the building is made of bricks. Same way, the dictionary is made of what? Dictionary is made of what? The words. If there are no words, then what is the use of dictionary? So that's the best answer we have. Number 47. Find the odd one out, the one which is different from the group. Fish, snake, crocodile, and whale. That's interesting. Well, fish is always in the water. Snake can be in the water. There are water snakes. Crocodile, it's an amphibian, right? So it is sometimes in the water, sometimes it's not in the water. And whale is not always in the water. So fish and whales are always in the water. Then snake, there are water snakes. There are snakes which are kind of like amphibians. There are snakes which are on the land as well. So if you look at that way, these two are always in the water. These two are not really inside the water. So we cannot get an answer that way. We need to pick the one which is different from the group. Then what else we do? Any other way of looking at it? The other thing would come to my mind is a snake is a reptile, crocodile is a reptile as well. Okay, that case two reptiles, and a whale is not a reptile and fish is not a reptile. So we don't get the answer again. So what else we have? Any other possibility we have? That means any other way of categorizing them. We try to categorize them based on like the living organisms which lives in water alone. So we take fish and whale. That case they live in the water. But the other two, if there are three organisms which lives in the water and one it doesn't live in the water, then that can be the answer. In this case we have two of them. They are not really always in the water. So that case that categorization may not work. The best way to categorize this case is what? Fish, snake, and crocodile. These are not really the mammals. At the same time, whale is a mammal. So that's the best answer we can have here. So the categorization is based on what? Mammals and non-mammals. The mammals, so only mammal is whale. All others are not really mammals. Number 48. Spoon, sword, knife, and fork. Well, the spoon, the knife and sword, a knife and fork, we use it in what? Kitchen, right? These are not really the weapons. A knife, still, knife can be a weapon, but kitchen knife in your home, we don't use the kitchen knife as a weapon. It's something which is we use in the kitchen, right? So that case, sword is not something what we use at home, right? If you have a sword at home, it is not really for like cutting something. It's totally different. It's used as a weapon. So if you use a particular word sword for a weapon, then the purpose is different. So in this case, sword is a weapon, and spoon, knife, and fork, these are not really the weapons. These are the utensils or the items which we use in kitchen and on the table as well. Number 49. In the following list of numerals, how many twos are followed by ones and not preceded by fours? Well, followed by ones. So we need to find number of twos which are followed by ones. Followed means immediately after that it would be 1. And at the same time, but not preceded by 4. So that means immediately before that, it cannot be a 4. It could be any other number, but it cannot be a 4. So we have to take like the 2 ones like this way, 2 and 1s. So here we have a 2-1 combination, but before that we have a 4. So that doesn't work. Here we have a 2-1 combination, and before that 2 we have a 1. Okay, that's possible. So we have one of it. Then we have a 2-1 combination. Before that's a 4. It doesn't work. Then we have like this is 1-2 combination. That doesn't work. Then we have 1-2. Here we have a 2-1. Before that 2 we have another 2. So that's possible. And here we have a 2-1. And before that 2-1, before that 2 we have a 1 here. So that's possible as well, right? So we have 1 such set, 2 such sets, and 3 sets are there. Then you have that's 2-1 here, but before that's 4, so it doesn't work. Then we have another 2, 1 here. Before that's a 4, it doesn't work. Then we have a 2, 1 here. Before that's a 1, so that's possible. Then we have a 2, 1 here. Before that's a 4, it doesn't work. This is 4, 1. That doesn't work. We need to have 2, 1. So this is what ultimately we have. We have 1, 2, 1. So that is after 2, there's a 1, and before 2, there shouldn't be a 4. So here what we have is 1. That's correct. So 1, 2, 3, 4 such groups are there. 4 such groups. So answer is 4. Next question here, 50. In a row of trees, one tree is fifth from either end of the row. Okay, one tree is fifth from the either end of the row. So this is the tree we have. That is fifth from the either end of the row. So that means there are 4 trees on the left and there are 4 trees on the right as well. So ultimately, what do you have? The answer is 9. Simple question. All right, so we have came to the end of this paper. We have done the discussions on the questions 26 to 50. These are logical reasoning questions. And it's a pleasure working with you guys. Thanks for watching. See you next time.